Hi, so I want to talk to you guys about the directions for our activity systems of equations practice. And this is going along with Chapter 9, Lesson 6, which is our chapter and lesson of the week. And the idea here is to graph two equations that are given to us. Some of them are going to be in slope-intercept form, which equals the y, which means the y equals mx plus b format, where they give us the slope as the coefficient of x, and they give us the y-intercept, which is the b value. Some of them, the equations I mean, might not be in that format, which if you remember, we have to go back to previous lessons where we talked about solving the equation for y. And we want to use our equation rules to get y by itself, usually on the left-hand side, and then we can go ahead and put it into slope-intercept form from there, and we can graph it. So I'm going to give you a couple of examples. Our first example is asking us to find the system of equations for y equals negative 1 half x minus 2 and y equals negative 3 halves x plus 2. Notice the slope for the second equation is an improper fraction. And that is one of the things that I wanted to address from our last week's lesson is that we want to leave our slope, for the most part, in a fraction. We do not want to turn it into a mixed number, and we really don't want to put it into a decimal because that fraction is helping us identify how many spaces or how many units we are moving to find their next point. So let's start by graphing y equals negative 1 half x minus 2, this first equation. And we're going to start by graphing a point at negative 2 on the y-axis. That is our y-intercept, negative 2. So we plot a point at negative 2 on the y-axis. And then we want to move according to the slope. So the slope is negative 1 half. What that means to us, though, is that we're going to move negative 1 spaces, which means down 1 space. And then the 2 is positive because we put the negative on the numerator. The 2 is positive, which means right. So we're going to go down 1 space, right 2 spaces, and plot our next point. Now we have 2 points. We can go ahead, we can graph our line, and we do that through the 2 points. We want to span the majority of the graph because we don't know where this intersection point may or may not be. Now we're going to graph the second equation. We're going to start at the y-intercept, which is positive 2. We're going to move according to the slope. So since it's negative, we're going to put the negative up with this 3, which means down 3 spaces, right 2. So negative 3, 1, 2, 3, and then over 2, 1, 2, plot our next point. We have 2 points. We can go ahead and we can graph our line. And we're going to notice that there's an intersection point down here at the lower right-hand side. So that would be at 1, 2, 3, 4 on the x-axis, 1, 2, 3, negative 4 on the y-axis. So we'd say that our solution here is 4, negative 4. And the solution is just the intersecting point of these two lines. Now our second example, we have an equation, y equals negative x plus 1, slope-intercept form. And our second equation is given in a standard form of x minus 3y equals 9. Since the second equation is not in slope-intercept form, we're going to have to solve it for y. So the first thing we want to do is we want to remove this x, so we subtract x on both sides. That gives us negative 3y equals negative x plus 9. Now, some of you may have said 9 minus x, and that is okay. I just like to keep my x's in front, so I take that negative x and I place it in front of the positive 9. The next thing we want to do is we want to get y by itself, so we have to get rid of the times negative 3, so we divide by negative 3 on both sides. Now the left-hand side, negative 3 divided by negative 3 is 1, and 1 times y is going to be y. On the right-hand side, this is kind of using the distributive property. So we're going to distribute this divide by negative 3 to the negative 1x and to the positive 9. So negative 1 divided by negative 3, the negatives cancel, and we're going to get 1/3. And then positive 9 divided by negative 3 is going to be negative 3. So our slope-intercept form, when we solve for y, is going to be y equals 1/3 x minus 3. So let's plot these points. We're going to start by going to positive 1 for the first equation because that is our slope slope-intercept form gives us the y-intercept of positive 1. And this negative x means negative 1x. Now, a negative 1 could be written as a fraction as negative 1 over 1. So that means that we're going to go down 1, right 1, and then we can graph our line. Now, once we convert this second equation to slope-intercept form, I'm going to ignore all of this work I did, and I'm just going to use the slope-intercept form. This gives me the y-intercept of negative 3, gives me a slope of 1/3, which means up 1, right 3, up 1, right 3. And I already see that my point is on the other line, so I know where my intersecting point is, but I'm going to graph my line anyway. I'm going to identify that intersecting point, and it is at 3, -2. So I write in my solution. So that's how I'd like you to fill out this activity for me. And then you're going to go ahead and click Turn In on Google Classroom. So make sure that you reach out. All right. If you have any questions, I do have my virtual office hours posted on our Google Classroom site. So please make sure that you go there, check them out. All right. If you need help, be sure to ask. Other than that, I hope you guys have a little bit of fun doing this activity. It's kind of a neat way to work with it, and it gives us a little bit of purpose for why we're graphing some of these equations. Take care, guys.